Hello friends. Recently my video From Measurements at Czech has been experiencing an unprecedented surge in views, along with a related influx of new subscribers. If it hasn't happened already, we could soon surpass that legendary milestone of 1,000 subscribers. Thank you all so much for that. In my YouTube posts, I promised you another video about flurfs, and since promises should be kept not only at Christmas, here it is. This will be another response to the measurements made by our colleagues from the other side of the barricade. This time, however, we're heading all the way to distant Brazil, where our truth seekers decided they could prove the flatness of our globe using geodetic methods. And here, we'll break down and explain exactly where our comrades from Brazil made mistakes. Anyone who's even a little interested in the flat earth hypothesis has probably already come across this documentary. Among others, it was also shared on his channel by Peter Lukesh, also known as Stopper7. Greetings to you, Peter. Lately, we've been getting notifications about this documentary from both flurfs and globers, and it occurred to me that it wouldn't be a bad idea to take a closer look at it. I've selected only those parts of the documentary that relate to geodesy and measurement. And before we get started, I have one more duty, which is to thank the sponsors of today's video. Thanks go to George Soros, Bill Gates, the Illuminati, and the Freemasons. I'd also like to thank NASA, ESA, and especially the lobbyists from globe manufacturers. Thank you. Without you, this video wouldn't have been made.
An unprecedented experiment developed by the researchers was to measure the geodesic curvature between two buildings over a long distance using high-precision GPS.
Considering the round planet, you have to mark a point from one extreme to the other, from a certain distance, precisely to prove mathematically whether the Earth is round or not. So we got two cities, far away. We take two buildings, one in a city in the south and one in a city in the north. This one in the south and this one in the north. What happens? If we measure this distance here at the base of the buildings, if the Earth is really spherical, when we measure buildings of the same height, when measuring the top, there has to be a difference, because if the Earth is spherical, it must have a superior length than the base.
Yes, that's only logical. On a round Earth, the two distances should be different, and I'm really curious how you plan to measure that over 3,000 kilometers. They must have some kind of powerful super device for that.
To carry out the experiment of the geodesic curvature, two buildings were chosen of the same height and sea level, as far apart from each other as possible. High-precision GPS measurements are done at the base and at the top of each building.
Wait a minute, are they measuring it using GPS? But that rounds things off and is based on the principle of a round Earth. Besides, flat earthers don't even accept it. When I was measuring, you dismissed GPS, but with them it doesn't bother you. Isn't that a bit of a double standard?
According to the theory of the spherical Earth, the distance of the measurements of the bases must be different than the measurements of the top, even in a few meters. But if the measurements are equal, this would show that the Earth has no curvature.
If they choose the right methodology, they should arrive at some differences in the distances. Well, we'll see how they do.
In order for the results to come out with the best possible precision, the CTZ researchers invited INCRA, the National Institute of Colonization and Agrarian Reform. This is one of the most respected organizations in Brazil, and one of the best in the world in the area of topography. INCRA engineers and technicians met with the researchers from the CTZ and Daquila to decide on the realization of the experiment, which would be evidence, or not, of the sphericity of the Earth.
Analytically, we will see if really this line here will be perpendicular in relation to this horizontal distance between the 2 points. There probably, in relation to the extension of this perpendicular line, to that baseline, I believe it will be larger.
Oh, dramatic slow motion video with a popping sound. I love that.
In the view of the INCRA technicians, the measures will be different. If this is true, it'll be one of the strongest evidences that the Earth is actually spherical. The first building chosen was at Torres Beach in Rio Grande do Sul. The second building was chosen in Natal, in Rio Grande do Norte, at a distance of 3,050 kilometers from each other, with the same altitude in relation to sea level.
Although the researchers do not specify the exact location of either building, nor their height or similar parameters they mention, I had to do a bit of digging and look up these details myself. And I succeeded. The first building is in the city of Torres, about 21 stories tall, which is roughly 63 meters. The second building is in the city of Natal and has about 22 stories, so that's around 66 meters. The distance between them checks out, that's those 3,050 kilometers. To give you a better idea, 3,050 kilometers is 1,520,000 tapirs lined up one after another. Both buildings are located close to the sea, so their similar elevation above sea level should also roughly match. The researchers also do not specify here what the distances between the bases and the roofs of the buildings should be. I couldn't resist and calculated it myself. For the base, it comes out to 3,020 kilometers and 958 meters, and for the roof, 3,020 kilometers and 989 meters. Just to clarify, 3,050 kilometers is the distance along the surface of the globe, and 3,020 is really the straight line, as shown in the picture. The difference between the distances for the bases and the roofs of the buildings is therefore 31 meters.
This is a GPS L1, L2 signal receiver. We'll do a reading from this point to chart the base. And from that base, we'll do the vertical readings relating to our goal. And afterwards, we will use another equipment, which is a total station, to make the readings of the vertical and horizontal angles.
They have points set by GPS here, and then they'll continue measuring with a total station, measuring angles and distances, so it's identical to how I measured at Geodetic. But for some reason my measurements were wrong, and this is considered perfectly fine.
To what conclusion did INCRA surveyors arrive in relation to the curvature of the Earth?
We're as tense as strings, waiting to see what conclusion they'll reach.
To carry out the last experiments, the researchers invited the consulted specialists at the start of the research to accompany and participate in the tests. Paulo Cesar Parra, civil engineer and geotechnical engineer, and a specialist in dam projects.
It's difficult. As an engineer, and I deal with the exact sciences. We carry this from childhood with these concepts. It is difficult to have another insight of this reality that we have since childhood.
Mauro Diaz, geographer and cartographer, specializing in aerophotogrammetry.
As is known by all mankind, the Earth has a spherical shape. And for me as a geographer and cartographer, it is difficult to accept that the Earth would not be a sphere.
In Minas Gerais, Brazil, the researchers performed the experiment of the geodesic curvature in the waters, accompanied by the guests.
We are here in the reservoir of the Trem Marae hydroelectric plant. We have the complete team. We are going to start the verification of the horizontality of the water here in the reservoir. It is a large reservoir. We are in a stretch that will give us up to 18 kilometers. The test aims, in other words, the following. The dam has a certain level. If the level GPS measures give the same, this means that there is no curvature of the Earth. If the measurements are different, then this means that there really exists an Earth curvature in relation to sea level.
If I understood correctly, the researchers are going to use GPS to measure the water level. And if they get the same or similar elevation values everywhere, then the Earth is flat. This experiment is set up incorrectly from the very beginning.
We are with a geodetic GPS already installed here. The surveyor is now going to another point, taking another point to start a triangulation, thus verifying, through this process, verifying the horizontality of the water. This first point in the elevation in relation to the sea level is of 556 meters altitude, so we're going to hit more than 3 points. This equipment, the geodetic GPS, we have two devices. One installed here to get this point, and the other goes to the other points. We get 3 points, all at the water level, and check the level of that point. The accuracy of this equipment for this distance, a distance of 10 to 20 kilometers, is around a few centimeters.
Researchers here have set up a so-called reference station, and with a second receiver they will travel to other points they want to measure. This is how measurements used to be done here as well. Today, these reference GPS stations have been replaced by fixed reference stations in every larger city, so now you can go out into the field with just a receiver and don't have to carry two devices. But it's clear that in the Brazilian wilderness, they don't have any other option.
No, that dramatic music is really great, honestly.
Engineer Paulo Cesar Parra supervised the entire experiment thoroughly.
Okay, we'll pass the coordinates now. We are now here at point B, 7.5 kilometers from the starting point, and there we had 556 meters altitude on the lagoon level.
What will be the results of the 3 points measured by the researchers?
Hey, just because you're looking into the device and pretending to measure doesn't mean you're actually doing it. For example, this guy, let's call him Pedro, is looking into a classic level. There's nothing wrong with that, but what exactly is he measuring on that reflective prism? A leveling staff with numbers belongs with a level, and that's where you read the elevation values. The reflective prism that the guy is holding by the water surface is actually an accessory for a total station. It's called a reflective prism because it reflects the laser beam sent by the total station, and that's how you measure distance. This level doesn't emit any such beam, and it can only move in the horizontal plane, so aiming directly at the prism is pretty difficult. Maybe they're aiming at the scale that's on the rod by the prism. As a last resort it might work, but even so, surveyors would probably find it pretty ridiculous.
Will they prove the flatness of the waters or the sphericity of the Earth?
They can undoubtedly demonstrate that flatness, but by using a completely incorrect measurement method.
What about the geodetic curvature experiment performed on the buildings? Measurements were done of the bases and tops of 2 buildings, one in Torres, Rio Grande do Sul, and another in Natal, Rio Grande do Norte, 3,050 kilometers apart from each other. According to the theory of the spherical Earth, the distance of the measurements of the bases must be different than the measurements of the top, even in a few meters. But if the measurements are equal, this would show that the Earth has no curvature. Remembering the opinion of the INCRA engineers before the experiment,
Probably there will be in relation to the extension of this line, perpendicular to the baseline. I believe it will be longer.
Thinking of the Earth as a globe, the initial expectation was that the measurements were different.
But when the results arrived, the base and the top measurements were the same, showing that the two buildings are leveled upright. And here the opening angle, where we read the point here, the base of the building and its height. As we do this calculation here, on this plane, we will always find this distance here. On this plane, we will always find this distance here.
The identical measurements of the distance between the bases and the tops prove that between the two buildings there is no curvature, proving that the Earth has no spherical shape.
Wrong, wrong, and wrong again. We can applaud the Brazilians for being able to build vertical buildings, but that's about it. The researchers made a huge mistake. Sure, they measured two buildings 3,000 kilometers apart, but they measured each one separately. From one location, they measured the first building, and from the other location, they measured the second one. Of course, that doesn't prove that the buildings are diverging from each other. This way, you have two local, independent measurements, and if you think about it, you'll realize this approach doesn't work. It's very similar to leveling measurements, where you break the entire sequence into smaller sections and thus avoid errors caused by curvature. If you wanted to conduct this experiment correctly, you have two options. The first is that you would stand on one of the buildings and measure the other from there. The second option is to stand, for example, halfway between the two buildings and measure both at once. In any case, you have to take such a measurement from a single location, not from two independent spots, and also fairly close to the buildings being measured. It's a great mystery to me why the engineers didn't take such an obvious thing into account. This is clear to any surveyor. The experiment with the buildings didn't work out. Hopefully they'll do better next time.
In the experiment of the geodesic curvature in the water, 3 points were obtained with a high-precision GPS on the Três Marias Dam in Minas Gerais, whose extension exceeds 70,000 meters.
This first point, the elevation in relation to sea level is at 556 meters altitude.
The second point also presented the same result, 556 meters of altitude. If the third point were different, the water would be following the curvature of the Earth. If the measurements are the same, it will be proven that there is no curvature, but indeed flatness in the waters. And the measure of the third point surprised the researchers.
Here we also obtained the same measure, 556 meters at the level of the lagoon. We analyzed the data collected by the equipment, and all points show the same result, the same altitude, thus showing that the water in the dam remains level.
Of course it's horizontal. After all, water follows the curvature of the Earth, but you can never measure curvature with GPS simply because of the way it works. It's completely clear to me that they didn't want to prove the curvature, but if this experiment were to be done correctly, they should have used a method that would actually measure the curvature, but the opposite is demonstrated. That's how it should work.
These data overthrow the theory of sphericity, because according to this theory, the water should follow the curvature of the Earth. Only in a curve there is no level.
The three altitude measurements were identical, proving the leveling of the water, proving that the Earth has no spherical shape.
Alright, so now I'll show you how it is with elevation above sea level and why GPS can't be used as proof of curvature. Let's first look at this on a flat Earth. The water level here will be at an elevation of 556 meters, and the same here and here. So with a GPS, you'll measure a similar value everywhere. If you measured here with a total station or a level, you wouldn't detect any drop. But if we take a round Earth, then with GPS, you'll get 556 meters here, here, and here as well. But that doesn't mean the Earth is flat. Researchers and proponents of the flat Earth hypothesis, for some reason, assume that on a round Earth, the line connecting points of the same elevation would look like this. Here, they measure 556 meters, and at these points, a few meters less. But that's not how it is. In reality, it's like this. Elevation above sea level follows the water surface. Logically, I'm starting to seriously doubt that these researchers are topographers or cartographers. If you wanted to measure curvature, you would have to use a total station or a level, not a GPS. The method of measurement with these instruments is completely different. With a GPS, you walk from point to point and measure the points directly on site, so you maintain the horizontal plane. With a total station, you measure from one point to another, and if the distance is great enough, the curvature will show. In the summer at Milada, my colleagues from the Space League of Justice and I also measured the water surface with a GPS, and we recorded similar values at different places on the lake. Then we measured with a total station, and there the curvature already became apparent. Definitely check out the documentary about these measurements. I'll put the link here in the video and in the description. This is how elevation above sea level works on a round Earth, so logically it's nonsense to measure it with a GPS. It's interesting and also quite confusing how flurfs contradict themselves when it comes to GPS. Here in the documentary, GPS is perfectly fine, probably because it supposedly proved the flat Earth, but when it comes to my measurements, which demonstrated the round one, suddenly its use is wrong because it rounds things off. Please, finally make up your mind about what stance you're going to take on GPS. The final summary of this experiment, it also failed, and quite badly at that. This documentary tries to come across as professional and must have cost a fortune. And in fact, it accomplished absolutely nothing. We're missing some measured data, and the researchers who present themselves as professional engineers and topographers made a ton of glaring mistakes that are obvious to any surveyor. The question is whether they did so unknowingly or deliberately to mislead an uninformed audience. People will say, well, surveyors know what they're doing, so it must be correct, and the Earth is flat. But when a surveyor thinks about it, they realize that everything is completely different. Let me know down in the comments how you see it. And of course, I'll be happy to answer any follow-up questions. If you liked the video, share it, like it, subscribe, and hit the bell. You know how it goes. See you next time in another video, and don't forget that everything is completely different.